All right, for my SVL students out here, I'm going to go over this quiz. This is the mid-unit trig quiz because I noticed a lot of people have been struggling on it. So now, little warning, the way mathexcelforschools.com works is it's a random number generator. So you won't have exactly these same numbers, but it'll basically be the same concepts. Okay, first up, question number one. You notice this is a 45, 45, 90 right triangle, okay? The model for a 45, 45, 90 is always the same. Let me do a little sketch here. Okay, so if this is if these base angles have to be equal, which means this is an isosceles right triangle. And here is what the model would look like. X times the square root of 2. Okay, so since this is a 45-degree angle and this is a 45-degree angle, then I'm going to make tick marks here, which mean those segments have to be the same length. So if this is 10, this has to be 10. So x is 10. Now, you could do the Pythagorean theorem, okay, and do a squared plus b squared equals c squared. But this is a shortcut. So if you have this memorized, okay, if you did the Pythagorean theorem, you would get this. So I know that in place of x over here, and I'll highlight real quick, okay, x times the square root of 2, which means this one up here is 10 times the square root of 2. Okay, let's go down to a 30, 60, 90 triangle. This is the second of the special right triangles. Okay, so if this is 30 and this is 90, this has to be 60. Here's what the model looks for 30, 60, 90, and I'm going to orient it the same way. That's not a very good triangle. Let's try that again. One more time. There we go. Okay, so if this is my 90-degree angle, this is 30, this is 60. I have a definitive short leg. Okay, I have a definitive long leg here, and then I've got the hypotenuse, which is always opposite of the 90-degree angle. And here's what the model looks like. Okay, this is x. The hypotenuse is always twice as big, and the long leg's the weird one, square root of 3. So if this is 24 and it's twice as big as the long leg, it means x is 12. I'll go put that over there. And again, look at the model. X, 2x, x times the square root of 3. So this down here would be, 12 times the square root of 3. Okay, let's go down to number 3. This is literally just filling in fractions, okay? It says type as an integer, which means a whole number, or a simplified fraction, no decimals. Okay, so step 1, you identify your reference angle. It says angle A, sine, cosine, tangent. Here is my reference angle. From there, I start naming sides. Okay, this across would be opposite. This side right here that's between my reference angle and the 90-degree angle, which is right next door, we call adjacent. And last but not least, the longest side of any right triangle, always opposite the 90 degrees, is called hyp, or hypotenuse. Okay, I'm going to write the acronym SOHCAHTOA. SOHCAHTOA. Okay, and the first letter of these acronyms tell me which trig name I'm using. So I've got an S, a C, and a T, which stands for sine, cosine, and tangent. And then the second part, the next two letters tells me what the fraction is going to be. So here, the O and H tells me opposite over hypotenuse. So if I look at my numbers here, opposite over hypotenuse. So the fraction I would have in this one is 8 over 17. Now, if I could reduce it, I will, but 17 is prime, so no number goes into it except 1 in itself. All right, next one, cosine. Adjacent over hypotenuse. Adjacent over hypotenuse. And I would get 15 over 17. And then last but not least, the tangent, or TOA. Opposite over adjacent. Opposite over adjacent. And that is 8/15. Okay, let's roll down to number 4 here. Okay, again, back to special right triangles. They give me both the models here. Okay, you'll notice this time, instead of different numbers I had here, same thing, x times the square root of 2. They just chose 1 as being x. 2x, x times the square root of 3. Again, 1 is the smallest leg of that triangle. So it says tangent of 30. Okay, so first off, find 30-degree angle up here. Boom, there's my reference angle. Tangent, which one of the trig ratios is that? That's the TOA part, right? So it tells me the tangent is what over what? Tangent of 30 degrees equals opposite over adjacent. So let's start naming things. There's my opposite. This is my adjacent. Okay, this one is going to create an issue. I would say 1 over the square root of 3. Now, I have this thing called rationalizing the denominator, okay, right here. And all that states is they don't like radicals in the bottom. Here's an easy way to fix it. I'm going to multiply it by 1. I'm going to multiply this whole fraction by 1. I'm going to multiply it by a fancy one. Okay, hopefully you all agree that square root of 3 over square root of 3 is 1. Okay, when I multiply a number by 1, it doesn't change it. Okay, but since it's a special one, it's going to manipulate it to look the way I like. On the top, I would get 1 times the square root of 3. On the bottom, if I were to multiply these together, I get, I get square root of 9. And square root of 9 turns into a nice whole number. So my final answer is square root of 3 over 3. Okay, let's go to the next page. Okay, solve for x. This is the true test of trig here. Again, I'm going to write SOHCAHTOA over the top. SOHCAHTOA. And this is an acronym to help you know which trig name to use and where things go in the fraction. So, step 1, reference angle. Step 2, start naming things. This across is opposite. This right here between the 90 degrees and the reference angle is adjacent. And I'll often say, okay, which one of these is the only one that has an O and an A in it? And I notice it's the TOA part. So that tells me the tangent of 31 degrees equals, and I have to make sure I put the right thing in the right part of the fraction. X over 41. If I flip-flop those, my answers are off. Okay, now, this is a number, tangent of 31, okay, and it all has to do with similar triangles, is a fraction that works for every triangle, no matter how big or how small. So for example, if I were to trace this triangle, and if I were to pull it off like this, and I still had a 31-degree angle over here, and let me blow this up a little bit, okay, but still 30 degrees right here. This is still 30, okay? Whatever these lengths are, opposite over adjacent, I'm going to get the same decimal or same fraction every single time. And that's what this number is. This is a pre-programmed number in our calculators, okay? So since it's a number, I'm going to turn it into a fraction. And I always recommend that you turn it into a fraction. I'm going to get rid of this. I'm going to put it over 1. And now we have a proportion, just like last unit on similarity. Cross multiply. This times this equals that times that. Let me highlight. Let me change my highlight color. I don't care which one you do. Okay, it can be the yellow stuff first or the orange stuff. I'm going to do the yellow stuff first. I always recommend throwing this number when I multiply in front. So I would have 41 times the tangent of 31 degrees equals x times 1 is just x. Okay, now it's a calculator problem. Now, one issue's on my calculator, and whatever type of calculator you use, you have to be in the right mode. Let me move this out of the way so I'm not blocking my math. So when I turn a calculator on, sometimes it's hidden. I have to be in degree mode because I see 31 degrees up there. Once you're in the right mode, you just type in 41 tangent of 31, and you get your answer. It says round to the nearest hundredth. That's 2 decimal places. So So 24.64. You got to be real careful. If you don't round appropriately right here, it will give you an incorrect answer. Okay? All right, let me clear that out. Let's go down to the next one. Okay, same thing, but in story form. I have a couple options here. I could do this. Whoops, what just happened there? I could figure out that this angle's 60 and work with that. Or I can do 30 degrees down here. Because these should be parallel lines, and going back a few units, okay, if these are parallel lines, then these two angles are alternate interior angles. They have to be identical, excuse me. I'm going to go with this guy. Here's my triangle, okay, I'm focusing on. Step one, go ahead and start naming things. So this would be opposite. This one here is adjacent. Again, I'm with tangent, the TOA part. So the tangent of 30 degrees equals opposite over adjacent. Now, this one's a little bit different than my last problem. My last problem, my variable was on top. This one's on bottom. So this is going to require one extra step. Again, tangent of 30 is a number. Turn it into a fraction. Cross multiply. This times this equals that times that. I don't care if you do the purple or the blue first. I'm going to do the purple. X times the tangent of 30 degrees equals 900 times 1. And then you'll notice right here, X times that number. Again, tangent of 30 is a fraction or decimal pre-programmed into my calculator. The opposite of multiplying that by that number is dividing. Remember to balance out your equations. Whatever you do on one side, you must do on the other. Those go away. Okay, now it's a calculator problem. Let me move this over here. Okay, so 900 divided by the tangent of 30 degrees. And I get this number, 1,558 point, round to the nearest whole number. So 1559. Okay, make sure you are answering the way they want you to. 1559. Okay, number 7. This one's a little bit different. Anytime I am looking for angles, I'm going to have to do inverses. So let me write that out here. Inverse. Okay, which means you're going to have, for example, like this little -1 power. That's the inverse button. It could be sine here, it could be cosine, it could be tangent. Okay, looking for angles. Looking for angles. I have to use the inverse buttons. So what I have here, name it, opposite. This is adjacent, again with the tangent. I'm surprised they don't switch it up. So the tangent, now this time I don't know the angle. This is called theta, it's a Greek T in the alphabet. We often use it for unknown angle measures. It's just like X or Y. Equals, okay, make sure you do opposite over adjacent, because again, TOA, right? 43 over 25. Now you'll notice I left some space here. Why did I do that? I am not quite done. My goal is to get this alone. Okay, how do I make this go away? Well, its opposite is tan inverse. So if I want that word tangent to go away, I have to take the inverse of it. Just like any algebra equation, whatever I do on one side, I must do on the other. And these cancel each other out. And now we have a calculator problem. So let me clear this out. Let me bring it over here. Okay, if you don't have a calculator like this, why does it keep wanting to go to that side? Desmos/scientific is amazing. There, I won't put it all the way to the top. There we go. So you'll notice it's in blue right above, second tan, 43 divided by 25. And there's my answer. Round to the nearest degree, so whole number. So that looks like 60 degrees. Okay, next one. Ooh, different one this time. Here's my reference angle. This is opposite. This is hypotenuse. So this time it's the SO part, okay, opposite and hypotenuse. So the sine of 42 degrees, which is just a decimal pre-programmed in my calculator, is A opposite over hypotenuse. Turn it into a fraction, cross multiply. I get 10 times the sine. You don't even need to put multiplication there. Equals A. Now it's a calculator problem. 10 sine of 42 degrees. Enter. Okay, round your answer to the nearest whole number. Looks like this is going to be 7 meters. All right, 2 to go. Reference angle. Opposite. Hype. Okay, I know it is the SO again. So I get the sine of 36 degrees equals 29 over C. Turn it into a fraction. Cross multiply. Okay, this will be one where I have to take that extra step. C times the sine of 36 degrees equals 29. This is a number. The opposite of multiplying by that number is dividing. Do it to both sides, balance out your equations. This goes away. And now it's a calculator problem. 29, let me clear this out. 29 divided by the sine of 36. And I get 49.33. What do they want us to round to? Nearest whole number again. So my answer is 49. And then let's do the last one. Oh, angle. Look at. I know I'm going to have to use the inverse button. Opposite. Hype again. Okay, just like the problem above. The sine of x, I don't know what x is, equals 5 over 17. I believe that's a 17. Let me see. Yep. Okay. I leave some space. Okay, how do I make this go away? The inverse. So take the inverse of both sides. These go away. And now, again, back to the calculator. Clear. Second sign. You can't do to the negative power of 1 like that. Don't caret -1. You actually have to find a button that has that little -1 power. And there's my final answer. And it says round to the nearest degree, 17 degrees. Hopefully that helps.